Okay, I had a request to show this whole page and the different diagrams together. Okay, and I added some detail on here too. Some of you may have noticed the mistake in the previous video on these angles here. This is not the 130 degrees, it's only 50 degrees here. It's actually this angle that's 130, but that's kind of a minor detail. Anyway, I don't think that confused anybody, hopefully. Alright, so I wrote some notes on here. In most archaeological texts that I've read, they use a term called objective piece instead of calling it a workpiece or a biface. And anything you detach from it is called a detached piece. We normally use the term flake, okay? But if you see these terms, that's what they mean. A detached piece is a flake, and an objective piece is the workpiece. Now, most people use biface and flake. I also use the terms core and workpiece. And in my definitions on Primitive Archer in the forum, I use the term core a lot. And the reason for that is it keeps things grouped neatly. This can be a core, which means you can remove flakes from a biface like this to use the flake for something like, small scrapers or whatever. You can actually, the flakes you remove from this biface can be used as tools themselves. So that's why I call this a core also. It can also be called a preform or a stage 1 biface, stage 2 bifaces, but I won't get into that. The basic terms are these terms. That's why I wrote them down here, in case you're reading and you've noticed what the heck is an objective piece and so on. And let's see. I tried to clarify some of this. I tried to do this video earlier and I messed up, so I'm going to do it again. But I scratched in some extra lines here. And the reason why I did this is because I remember from the previous video that I was saying something about this angle here needs to be acute so that it's easier to remove a flake, okay? Now, the reason why it's easier to remove a flake is because there's not as much material to overcome, okay? That's why it's a little bit easier than if you were to pretend this was the edge of the piece and this angle was greater than 90 and then try to remove a flake, because you have to overcome a lot more material in here. And it slips more easily off of this one, not because this is magically more slippery than that. It slips off because it's so difficult to overcome this extra material in here, this difference in here. Okay, this difference in mass here makes it very difficult to remove a flake. Okay, it can be done. You can strike and remove a flake from a obtuse edge, and I'll get into that in a minute. But that's why I drew this line in here. Anyway, so let me try this again. I say again because I tried this earlier and I messed up. Alright, so this video is going to be about flake initiation. And I don't know if it's called this in archaeological texts. I think it is. But that's what I'm going to call it here. Anyway, I'm going to divide this into two different types of flake initiation, two basic types. Okay, and this is a workpiece here. Workpiece here. This is a solid part. Now, you can either hit or put pressure above the edge or right on the edge. Okay, two basic different types. Now most books will show this type here, and what this type is, it's more of a peeling of the flake, okay? And what happens is when you put pressure or percussion forces on the very tip, it kind of stretches out this surface, and you're going to have a flake start somewhere along here, okay? And it usually starts like this, and then you get the bulb, and then you get the continuation, okay? This is normally how long flakes are made, with the force directly on the tip. And this requires a soft, in most cases, some sort of soft bit on your tool, okay? And the force isn't really that way here. It's more like this, okay? Some slight inward, but mostly downward, okay? And these arrows, if you want to get into the physics of it, these are vectors, which equals the force and direction. It's not necessarily a plus sign, but force and direction will give you a vector, okay? Now this vector changes with different types of pressure and different types of percussion and different angles, of course. And I'll get into that a little bit here. But you also notice that this bit, I drew it kind of like this. But for long flakes, as I was describing in the other video, it usually starts like this. So let's try this again here. Okay. Now the bit or the tool itself will dimple okay, as you apply force. And that's what you want. You want it to grab the edge in order to create enough tension forces on this to initiate this little crack, and it'll start to flake. Now it's more like that. It's hard to describe in an illustration because these forces are all, or these arrangements are all kind of dynamic, which means they change position. It may look like this once it initiates, but when it starts, and I was getting into this in the other video, starting these things is different than than the actual initiation. The positions of everything are different. You know, you'll start up here, apply pressure or force, and it'll deform. You'll get probably some bending in your tool with pressure or with a horizontal punch with force driven down before it detaches, before the flake detaches. And then once the flake detaches, this will straighten out. The position of these things may be right like here just before the detachment, but just before the strike, or just as you're starting to apply pressure, it may be up here somewhere. Okay, so these diagrams that show you how to place the tool on the workpiece are usually right at the moment of initiation, which is different from the moment of actually making contact between the tool and the workpiece. It may be way up here somewhere, and then everything moves down as you're applying more and more and more pressure, and then finally detaches. And that angle where it finally detaches is a mystery to me, believe it or not. I can't tell you exactly where that happens. And I don't think anyone can, because many different forces and variables are at play. Sometimes it may detach down here, sometimes it may detach right away up here. The ideal position, I think, and I might measure this later, is probably almost, lined up with the center lines. Somewhere in there. It can't be too far down because you'll get a short flake. It works a lot better if there's some bridging going on where this angle here is less than 180 between this center line and that center line, and then it detaches somewhere down here. Okay, same with percussion. You start up here with a horizontal punch, for instance, and everything will deform and bend, and then it'll snap, and you'll be down here somewhere where it actually initiates. Okay, so that's this one. That's number 2. There's another way to do it also here, and I don't know if there's scientific terms for these two different types, but I'm just going to go 1 and 2. You can apply pressure or percussion way above the edge to forcefully initiate a flake. Okay, and this usually happens. This type here is maybe not usually, but it's common with hammerstones or direct percussion. Let's just say hammerstone. You can use a hammerstone, to strike above the edge, or you can use a hammerstone to strike right on the edge. This is usually for larger flakes, and this will directly initiate a flake. Okay, right here at the point of contact. This initiation happens away from the point of contact. Okay, 2 different types of initiation here, and I'll probably need to go into this further for you new guys. I use both of these types in my videos, both of this type, and sometimes I'll start with this. I'll hit high up on the platform, and I find it's not working. I'll hit lower, or I'll hit lower and I'll find it's not working right. I'll hit higher. I'll switch in between. Sometimes I do a workpiece with mainly this type of percussion or pressure, and sometimes I use this type of percussion through most of the workpiece. So knowing the difference is what takes a long time to learn. That's the skill of the Flintknapper. You have to know the differences, is where the skill comes in. But just as a beginner, know that there are differences here between these flake initiations, and that's important, okay? Because with this type of initiation, you normally cannot get long flakes. Normally, okay? The secret of getting a long flake, one secret, or one main component, is when your workpiece is in contact with the tool throughout the entire removal of the flake. And I'll say that again. The bit of the tool, or the tool itself, needs to be in contact with the flake on the platform throughout the entire removal process to get a long flake. If somehow it bounces off or slips off or doesn't maintain contact very long, you'll get a short flake, no matter how well you've positioned it, no matter what kind of force you're using. If you're using exactly the right force, exactly the right angle, exactly the right materials, everything's perfect. If you don't maintain contact with this platform, you are not going to get a long flake. Okay? So, how do you maintain contact? All right, good question. Let's see. Again, I could probably make $1 million answering that question in a book. But let's see. All right, so this is a flake. That's not a very good representation. And let's say this is the tool here. Alright, well, let's have it making better contact. Okay. Now you want some inward force and you want some downward force. Okay. Both to attach this long flake. And a softer material slash more elastic works better than hard material like a stone, like a hammerstone. Okay, you can get much longer flakes relative to the width of the flake with a softer or more elastic tool. And you know, most people use antler. I would say the next softest would be bone, and then aluminum, and copper, and then everything else. Steel is in there somewhere, and you know, hammerstones. Okay. I would say horn. Regular horn is softer than antler, and it can be used also. Okay. And I've seen extremely long flakes done with horn, either bison horn or cow horn, because it does have some elasticity. It snaps back and forth. It'll dimple, but it'll snap back into shape. And while it's snapping back into shape, it's helping to maintain this contact during this flake removal. And the tools can help too. The actual body of the tool, like the handle, if it's flexible, you know, if you got some flexibility in these things, in the tool itself, and you're applying pressure and it detaches, as this tool straightens out, as it snaps straight, it helps to is maintaining contact with that platform during that straightening, which is the explanation why flexible pressure flakers, for instance, can drive long flakes more easily than a stiff pressure flaker. At least for some people. I mean, maybe even most people. All right, and it's the same thing with horizontal punch technique. The striker or the mallet will deform the striker in the same way that, you know, applying a lot of pressure does, and that time it takes to straighten back out helps to maintain contact with the platform of the flake during this removal, producing a longer flake. Okay, so there's two components. You have to have all the variables perfect, and you have to maintain contact. And I think I have a video on maintaining contact. But that's okay. It's good to repeat these things. All right. If you don't have all of these together, you're not going to have the results you want. Like you can maintain all the contact you want with the platform, but if you don't have the other variables perfect, like, you know, material type, angles, force, tool size, all that, you're not going to get your results either. It's a combination of these two things. Okay. So just to recap here, there are two different types of initiations. One is directly at the point of contact with the tool, and one that's away from the point of contact with the tool. Okay? And there's two main things to think about when detaching these long flakes. You have to have all the variables perfect, and all the angles, the forces, and everything perfect, and you have to maintain contact with the platform all the way through this process, because if it bounces off or doesn't maintain contact, all these variables go to waste. Okay. Now, one more thing before I forget. One of the main complaints that I have, or one of the main issues for new people, is I'm applying way too much force to get these things to work. I mean, I have to apply way too much force, I think, to get these things to work. And why is that? I'm having to really smack the tools to such an extent that I'm ruining my tools. I'm breaking my bifaces in half. I just can't get a balance between the amount of force I need and the flakes I want. It's always too much force and long flakes, but something broken, or not enough force and short flakes, and everything staying intact. How do I get the proper balance there? Okay, that's a very difficult question as well. And let's see, if you're hitting too hard, if you're having to hit too hard, okay, I'm hitting way too hard. One of the issues is a lot of new guys using tough material run into this problem. That's the main problem. Material is very, very tough, but you can also have looseness in the bits, in your tool bits. Okay, you can also have platforms that are too strong. Or dull. Let's see, what else did I have? I had some on the other page. Mallet is too light. The bit is too large. Placement is too high. Okay. Placement of the tool is too high, like right here. It's too high up, and then you have to apply a lot of pressure to get that to initiate. Bit too large, so there's too much surface area on the tip of this bit. There's too much surface area, and you're having to overcome way too much material to get that flake to remove. So you need to try a smaller bit. Or if you're using indirect percussion or some sort of punch work, if your mallet's too light, you're going to have to hit really, really hard. Okay, but this also applies to grip too loose. You have to strengthen your grip for pressure. If your grip is not extremely strong and it's kind of loose, you'll have to, seemingly have to apply way too much pressure. Okay, so you can increase the strength of your grip to overcome that. Okay, so these are some of the issues that you'll run into that cause you to hit too hard. So you just need to use material that's less tough. Glass is probably the least tough, but try to find something between glass and floor tile. And usually see what's a lot of nappers like to use dacite. I recommend that for beginners. We'll just leave it at that. There's a bunch of other stuff. I won't get into that. I don't have time. We're running close to 30 minutes. Anyway, don't dull your platforms as much. Make sure you tighten up your bits so there's no play in any of the bits if you have them, if you have composite tools that have bits. Placement too high on the platform, the bit's too large, which means there's too much surface area, the mallet's too light, so forth. Alright, so the other issue that I have a lot of questions on is how much force, what size of the tool, and what angle exactly. Okay, these three questions come up a lot. Okay, and to answer all of these three is the basically the same answer: is start small and work your way up. Okay, what angle exactly? You start small and work your way up. And let me try to illustrate that on here in the time I have left here. And let's see. You start with very, you don't start up here. You start down here with the angles. So you're just knocking off small flakes, small flakes, small flakes. And then you slowly experiment with increasing this angle. Or basically what you're doing is you're increasing the steepness or the acuteness of this angle. And then eventually you'll find a spot here that you'll achieve some success at removing longer flakes, but then you'll have to overcome the step fracture problem, and I'll get into that in a different video. Alright, but start like this, low with the angles like this. Also start with a small bit. If that bit's not giving you what you need, work your way up. And with force, hit, with small amounts of force, and then work your way up. Okay? And if you are working your way up with the force and the size of the bits and the angles, and you're still not getting the results you want, just look at these different variables. Okay? And the number one cause of not being able to get the flakes you want is the material. Most guys work with material that's way too tough. Alright, I still got it's only 28 minutes. Okay, so dacite, hornstone. I'm trying to write through the viewfinder. Hornstone, Georgetown, flint. Hornstone comes from Kentucky or Indiana, I think. Two different types. I'm not sure if that's the abbreviation for Indiana. Anyway, dacite, hornstone, Georgetown. I don't know. Those are the big three that I can think of that are very good for beginners. Because you don't have to do anything. You don't have to heat treat these. These are raw. Okay, none of these need heat treatment. Yeah. Okay, so hopefully that will help. I think I covered all the main points, and I'll get into more precise demonstrations with actual workpieces and tools in the next videos. I'll probably get into one more lecture like this to round out this this series. But that's it for now. Okay.